All right, guys, so I'm gonna do lesson 3-8 in this video. Expectations are that you completed the GeoGebra activity before you actually watch this video. So in your activity, you should have noticed that when you graph parallel lines, their slopes were the same. When you graphed perpendicular lines, you should have noticed that their slopes are opposite reciprocals. So what does that mean? So that means that suppose that you have one line and its slope is 3/4. If it's perpendicular to that line, then its slope would be an opposite reciprocal. It's going to be 4/3, and it's going to be negative. Perpendicular lines will always have slopes where one is positive and one is negative. Most of the time, unless the line is horizontal and vertical, then that's a different scenario. But for most cases, your slope will always be one positive, one negative, and then one will be the reciprocal of the other. So that's what opposite reciprocal means. Oblique lines just means that they're lines that intersect, but not perpendicular. So they just intersect kind of like in a generic way, not in any special way. Coinciding lines are two lines that have the same slope and the same y-intercept. So first thing we're going to do, or a lot of what we're going to do, is we're going to find the slope of multiple lines, and we're going to determine if they're parallel, perpendicular, or oblique. So if they give you a graph, don't use the formula y2 minus y1, x2 over x1. I'd rather just do rise over run. So one thing that you'll want to do is look for good points on the graph. So I see that on L1, there's a good point right there, and then there's a good point right there. So the next thing I'll want to do is just make a triangle. Doesn't matter if you make the triangle on the top or on the bottom. You'll still get the same answer. So this has a rise of 1 and a run of 3. So the slope for this one would be 1/3. This has a positive slope because both movements, if you go left to right, are positive. +3 to the right and +1 up. I always go left to right, just like you read a book. L2, I'll do the same thing. I'm going to select the good point. Let's see here. It's kind of hard to tell. There's a good point here, and then there's a good point here. Now, at first glance, these lines look parallel, but we always want to find their slope just to be sure. So I'm going to do the same thing. I'm going to do rise over run. This has a run of 4 and a rise of 1. So this has a slope of +1/4. Notice that their slopes are very close, but they're different. So they're not parallel, they're not perpendicular. These will intersect eventually. So these lines are what we call oblique. They're going to intersect at some point. Let's look at example 2. And a lot of this is the same. Notice that I've already done the rise over the run. You don't have to use the points they give you. You can find your own points on the graph. Notice that both of these have a rise and run of 3. They're both positive. Since they both have the same slope, then I know that the lines are parallel. When I look at example 3, they look perpendicular, but I'm not sure. So you want to justify that by actually doing the slope of each line. So if I do M1, I'm just going to use the 2 points they gave me because they're close enough. It has a rise of 3, a run of 2. So the slope of line M1 would be 3/2. It has a positive slope going left to right. They both have positive movements. If I look at line number 2, I think I'm going to have to use the points they gave me. So I'm going to go make a triangle from point to point. It has a rise of 1, 2, 3, -4 because it goes down, and then it goes to the right. 1, 2, 3, 4, 5, +5. So it has a slope of -4, 5. The slopes are different. They're not opposite reciprocals of each other, so therefore the lines are oblique. Okay, they look perpendicular, but they're not. So where's example 4? Let's see. Here we go. Okay, so example 4, you'll want to do the same thing. Now, can you be using the formula at the top? You can, but I just find it easier that when you have a graph, we'll do some examples where we're actually practicing using the formula. So finding the slope of GH, that would be, well, I think on this one, notice, I like to use points that are closer together if possible. That just has a slope of 1/1, so the slope is just +1. If I look at the slope of f to e, same scenario, I can just go negative 1, 1. So it has a slope of negative 1, or 1 over 1, negative 1 over 1. So these lines are perpendicular because they're opposite reciprocals of each other. It's kind of hard to tell because it's just the number 1, but these lines are perpendicular. Now, in some cases, you won't have a graph. You'll have to actually use the formula y2 minus y1 and x2 minus x1. So I'm going to find the slope of line 3 first. I'm going to do, remember that this is x1, this is y1, x2, y2. We can label the other points the same. We can do this is x1, y1, x2, y2. We'll have to find the slope of each of those lines separately. So always just be careful with your negatives. So if I do line 3, it will be y2 minus y1, or 2 minus 6, and then negative 1 minus negative 15. Always be careful with your double negatives. They become positive. So on the top, we'll do 2 minus 6, which gives you negative 4. Negative 1 plus 13 gives you 12. Always reduce if possible. That reduces by 3 on top. I'm sorry, by 4. So that reduces to negative third. Now let's do the slope of the second line, line 4. So that would be 7 minus 6, and then 6 is 3, which gives you 1 over 3. Now when you compare the slopes, they're not the same. They're not opposite reciprocals. Now they have opposite signs, but not reciprocals. So these are not perpendicular, but they are oblique. They just intersect. They have different slopes. Example 6, you would do the same. All these can be found in the Google Classroom. So I do have all these notes. I think there's a mistake though. My video is correct. I think there's an error on example 1 or 2. I forgot which one, but when you look on the Google Slides, you'll notice that there's actually a mistake on there. All right, so line 3, we'll do the same thing here. You'll use line 3. We'll do negative 1 minus 7, 3 minus 2 is going to give you negative 8 over 1. For line 4, we're going to subtract y2 minus y1. And the same on the bottom, those become positive. So we're going to get 1 over 10. So again, you'll notice that these slopes are different, so these lines would be oblique. And so on and so on. I mean, you would continue doing these. You can look on the Google Classroom to see detailed examples, but they're pretty much done the same. So for your homework, you will have to know how to convert from standard form, which I'm circling on your screen, to slope-intercept form, which is y is equal to mx plus b. To do that, you want to subtract 2x on both sides, bring down to 3y, and then divide both sides by 3. And so that gives you, from standard to slope-intercept, the number in front of your x is your slope. So the slope of this line is negative 2/3. The slope of the line on the right is negative 2/3. They both have the same slope and a different y-intercept. That means that these lines would be parallel. Then for these right here, remember that lines are parallel, have the same slope. We're going to find the equation of a line that is parallel to y is equal to negative 2/3 x minus 1 and goes through the point 3, 5. So I know that I need an equation that has the same slope and goes through point 3, 5. So I'm just going to put it into point slope form. So this would be y minus, this is x1, this is y1, so I'm going to put minus 5. Your slope is negative 2/3, and then we're going to do minus the x, which is 3, x1, and then you go from there. Now, one thing though, on your SAVIS homework, you do have to put some of the answers in slope-intercept, which is mx plus b. So if it's in point slope, you'll have to solve for y. So what you'll want to do is you want to distribute the negative 2/3 into the parentheses. So that's going to give you negative 2/3 x. Negative 2/3 times negative 3 gives you positive 2. And then we'll get the y by itself, add 5 both sides. So you get y is equal to negative 2/3 x, 7. Now it's in slope-intercept form. Again, sometimes on Savvis, you can leave it in point slope, or it might ask for it in slope-intercept form. So just kind of be aware of that. Last thing I want to talk about is that if it does ask for the equation of a line that's perpendicular to this line, but to this point, just remember that the slopes have to be opposite reciprocals. So instead of writing negative 2/3, you have to do the opposite reciprocal of that, which would be positive 3/2, and it still goes 3, 5. So then you put it in point slope. We're going to do y minus y1, which is 5. Your slope is now 3/2, x is 3, and there's your answer. Just remember that if it does want it in slope intercept, you do have to multiply or solve for y on that. All right, guys, well, I hope this helps. For the detailed notes, please look at the self-paced pair deck. It'll give you all the notes worked out for you. So once you're done with this, work on homework 3-8 and 3-7. Those of you that have credit protection, please fill out the form that has been assigned to you. If you did not get a credit protection form, that means you passed the first 9 weeks. All right, guys, you have a great weekend, and I will see you on Tuesday.